Okay, here we are doing another limit. We have the same outline set up on the page for doing this proof. We are going to show that the limit as x approaches 6 of 7 minus 4x over 3 is equal to -1. And in general, we seek delta such that for every positive epsilon, 0 less than the absolute value of x minus a less than delta produces the absolute value of f of x minus a l is less than epsilon. Okay, so we have to find the appropriate values here. In this particular given problem, we have a is equal to 6, f of x is the function 7 minus 4x over 3, and the limit L is -1. So let's restate what we're seeking in the cloud. We seek delta, a positive distance delta, such that for all positive epsilon, that upside down A means for all positive epsilon, 0 less than absolute value of x minus 6 less than delta produces the absolute value of the function 7 minus 4x over 3 minus the limit -1 is less than epsilon. Okay, so we're assuming that 0 is less than the absolute value of x minus 6 is less than delta. And we're going to show by choosing the appropriate delta that the absolute value of 7 minus 4x over 3 minus the -1 is less than epsilon. Okay, so the first step is to relate the absolute value of f of x minus L and the absolute value of x minus a. So in particular, we're going to relate the absolute value of our f, 7 minus 4x over 3, minus our L, -1, and our x minus a, which is x minus 6, absolute value, and decide in this situation what delta must be equal to. Okay, so start with the absolute value of f of x minus L. That's equal to the absolute value of 7 minus 4x over 3 plus 1, which is equal, when we simplify, to the absolute value of 8 minus 4x over 3, which is the absolute value of 4 times the absolute value of 2 minus x over 3 when we factored out the 4. But the absolute value of 4 is just 4, so we have 4 times, now let's just rearrange the terms inside of the absolute value. That's negative x over 3 plus 2. I like the x in the front. And now let's factor a -1/3 out of that and bust it out. So we have the absolute value of 4 times the absolute value of -1/3 times the absolute value of x minus 6. Well, the absolute value of those two numbers is 4 times 1/3, and that's 4/3. Now that's going to be smaller than 4/3 times delta. And why is that true? It's true because we made the assumption that the absolute value of x minus 6 is smaller than delta. Okay? All right, so 4/3 times that's going to be smaller than 4/3 times delta. Now, we want the last thing in this line to equal epsilon. All right, so to choose epsilon, well, we'll choose epsilon equals the last thing we have here, 4/3 times delta, and we'll solve that for delta to get delta equals 3/4 times epsilon. That is the delta that's going to work in our proof. Same idea that we've been using previously. So step 2, we're going to assume that the absolute value of x minus a is less than delta, and we're going to choose for this case delta equals 3/4 times epsilon, then show by substitution that the f of x minus L absolute value is less than epsilon. Okay, so proof. Assume absolute value of x minus 6 is less than delta, and let delta equal 3/4 times epsilon that we found in the previous step. Then let's do our proof. Absolute value of f of x minus L is equal to the absolute value of 7 minus 4x over 3 minus a -1, which is equal to 4/3 factored out, take the absolute value, it's positive, times x minus 6. Well, that's less than 4/3 times delta because of our assumption, and that equals 4/3 times 3/4 because we let delta equal 3/4 times epsilon, and the 3/4 and 4/3 cancel, and we get epsilon at the end, which is exactly what we had to show. Conclusion: we have shown the limit as x approaches 6 of 7 minus 4x over 3 is equal to -1.